This is part 9 of the review, and we are now looking at solving equations that feature fractional exponents. So we're going to look at number 9. A fractional exponent is an exponent that's in the form of a fraction. So what we need to do is understand what a fractional exponent is. So I'm going to take this fractional exponent, and I'm going to come over here, and this is written as x to the 1/2. Now there's two ways that you can write this. There's two ways it's understood. Number one, the bottom number is the root that you're taking, so like the square root. The top number is the exponent you stick on the expression underneath, so that would be square root of x. Another way to write x to the 1/2 is the bottom number is the root you're taking. This is the number that goes underneath, and that's the exponent you put all of them to. So this one and this one are two different ways to write the same thing. But basically, when you have a 2, when you have square root, you don't have to write the 2 in there. It's understood that it's a square root. So x to the 1/2 is essentially the square root of x. That's what this is. To the 1/2 is the square root. So what I got over here is I'm going to rewrite this as 4 square root of x equals 16. Once I've done that, I can solve it just like a regular equation. So I'm going to divide both sides by 4. So the square root of x equals 4. Now, how do we solve that? Well, for the square root of x to equal 4, remember we talked about inverses. We're going to take the opposite. If I have square root, the inverse operation, the opposite is to square it. So square root squared just leaves me with x, and 4 squared is 16. So 16 is our answer. That's how you do 9a. So let's look at 9b. Paper up a little bit. So let's look at 9b. 9b is 2 times the square root of x minus 3 plus 4 equals 6. And so we want to solve for the value of x. So the first thing I'm going to do is I'm going to move the 4. I don't have any fractional exponents, so I don't have to worry about that. I'm going to move the 4 over. That leaves me with 2. Remember, we always want to isolate the radical. Times x minus 3 equals 2. So let's isolate our radical again. Remember, this is what we want to isolate, is the radical expression. I am now going to divide both sides by 2. Because that divides out to 1. That gives me the square root of x minus 3 equals 1. So now I'm going to square both sides. And the reason I'm going to square both sides is because I have square root and I want to do the inverse operation. So square root squared is just x minus 3 equals 1. And to solve it and finish it, I'm going to add the 3. So x equals 4. So that's how I solve that one. The last one, we'll look at C. I'll go ahead and do that one over here. Hopefully everybody can see it. The last one for C is 3 times x plus 2 to the 1/2 plus 1 equals 28. So what I want to do first is, again, I want to isolate my radical. But I'm going to rewrite this 1/2. What did we say 1/2 was the equivalent of? Square root. This right here is the equivalent of this. That's what square root means. So now I want to isolate that radical expression. So the first thing I'm going to do is I'm going to subtract 1. So I have 3 times x plus 2 equals 27. Again, I want to isolate the radical expression, so now I need to look at doing something to both sides equally. So what I'm going to do is I'm going to divide both sides by 3. So I end up with the square root of x plus 2 equals 9. And what, boys and girls, is the inverse operation of square root? It is squared. So I'm going to square both sides to get rid of that square root, and I end up with x plus 2 equals 81, because 9 squared is 81. Then my last step will just be to isolate the x. So x equals 79. And that's how you solve equations using fractional exponents.